To all of our new students, welcome to the University of Tokyo. On behalf of the entire university, I extend my heartfelt congratulations. As members of the UTokyo community, you will learn and think about many different things. You will interact and sometimes compete with new friends you meet here as you pursue knowledge in your chosen fields. As some of you may know, this past January, Professor Svante Pääbo, director of the Max Planck Institute for Evolutionary Anthropology in Leibniz, Germany, gave a lecture here in Yasuda Auditorium. Last year, Dr. Pääbo received the Nobel Prize in Physiology or Medicine. In fact, today is the announcement day for the same prize this evening. But he received this prize for his groundbreaking research on the genomes of the extinct Neanderthal and Denisovan hominins and the implications for human evolution. His pioneering work has led to great advances in the new scientific discipline of paleogenomics, with impacts spanning from the natural sciences to the social sciences and humanities. Using the technology they worked hard to develop over more than 30 years, his research group has been analyzing trace amounts of DNA extracted from ancient human bones and cave deposits dating back hundreds of thousands of years. Their results have given us a much deeper understanding of human origins and our evolutionary history. For example, analysis of ancient DNA over the past decade has revealed that Neanderthals did not simply go extinct. Rather, over hundreds of thousands of years, they repeatedly interbred with Homo sapiens and spread along complex routes across the globe. The research also revealed the existence of another now extinct hominin species, the Denisovans. New insights are also emerging about the movement of people in and around the Japan archipelago. It used to be believed that Japan was home for many millennia to what are called the Jomon people. Then, about 2,000 years ago, the Jomon people were joined by the Yayoi people migrating from Asia. However, analysis of ancient DNA has revealed that around 6,000 years ago, people in southern Korea already had Jomon-like characteristics that are similar to those of modern Japanese. So the conventional story of today's Japanese being descended from the indigenous Jomon and immigrant Yayoi now has to be revised. Going forward, genome analysis of human bones and other remnants in and around Japan, together with archaeological findings, should give us an even more detailed understanding of human migration in past millennia. The term genome refers to the entire set of genetic information that makes up an organism. The concept originated in the 1920s from the analysis of sets of chromosomes in the reproductive cells of plants. Later, genome came to mean the full genetic DNA sequence. Our genes and DNA are sometimes regarded as mysterious and all-powerful. Some people seem to believe that genetic information determines everything about an individual's body and personality, and that it controls even what diseases we get. But that is a misunderstanding. Genes are merely blueprints written with letters called bases. The term blueprint might conjure an image of a detailed plan listing dimensions and shapes with no empty areas. In fact, however, the portion of our DNA that actually codes proteins, that is, the genes, is extremely small, around just 1%. So initially, the remaining 99% of DNA was thought to be useless junk. But as genome research has progressed, it has become clearer that those regions contain information that serves as instructions on how to use the genes. We have also learned that decoding only the base sequences of a genome is not enough to understand the complex biological mechanisms. One of the major milestones in the field of genome research, or even in science as a whole, was the Human Genome Project, launched in 1990. The project aimed to decipher the entire sequence of human DNA. With the technology available then, only a few hundred bases could be identified at a time. The goal was to read out all 3 billion bases, so over 1,000 researchers in 6 countries worked together, making time-consuming and steady progress. After more than a decade and the investment of some $3 billion, the completion of the first draft sequence was announced in June the year 2000. When we think about the nature of that research, it is symbolic that the completion of the first draft was announced at a press conference attended not only by Dr. Francis Collins of the Human Genome Project, but also the US President and the Prime Minister of the British Prime Minister, and Dr. Craig Venter of Cellular Genomics Corporation. Dr. Venter had been affiliated with the Human Genome Project at first, but while the project was still underway, he moved to the private sector, where he competed with the project and helped to accelerate the decoding. After that press conference, at that press conference, President Bill Clinton made an insightful comment. He said, and I quote, "When Galileo discovered he could use the tools of mathematics and mechanics to understand the motion of celestial bodies, he felt, in the words of one eminent researcher, that he had learned the language in which God created the universe." President Clinton continued, "Today, we are learning the language in which God created life." That joint press conference touched on several issues faced by universities today. The first is the importance of cooperation between the public and private sectors. At the conference, President Clinton also noted that, quote, "A robust and healthy competition is essential to the progress of science." While direct government investment in basic research is important, governments must also help universities and industry make long-term research investments themselves. In the Human Genome Project, private sector investment was essential. Without it, automated DNA sequencers would probably not have been developed so quickly. That thinking accords with the basic philosophy of industry-academia co-creation that we are now actively promoting at UTokyo. Our current initiative to encourage endowment-based research programs is an example of efforts by academia to work together with industry and the private sector. We seek to build a foundation for serving the common interests of society, and thus make our world a better place for everyone. This is in line with one of the goals stated in UTokyo Compass, to work hand in hand with society to create an ideal vision for a shared future. This past summer, while on a trip to the west coast of the United States, I had a chance to visit the Monterey Bay Aquarium Research Institute. That institute was founded through private contributions from David Packard, one of the founders of the Hewlett-Packard Company. It has been the birthplace of many technological innovations, including a system called the ESP, Environmental Sample Processor, for automatically collecting DNA samples from the ocean. One unique feature of this institute is its commitment to sharing the observations and imagery obtained through their cutting-edge technology directly with public, through exhibitions at the aquarium and other means. Their initiatives embody the same principle we advocate in UTokyo Compass of building a virtuous circle of confidence and support. This illustrates how academic research institutions can leverage support from the private sector to expand their activities, share their achievements with the public, and broaden their support to attract further backing for future endeavors. Another important lesson from the Human Genome Project is what is made possible by data accumulation and open access. The availability of the genome data to the public encouraged the development of the next generation of high-speed sequencers. That resulted 22 years later in a more complete decoding of the human genome. It became possible for many more scientists to use genomic information in their research. Medical research has made particularly remarkable progress. Utilizing the draft human genome sequence and more advanced and widely adopted sequencing technology, it is now possible to decipher an individual's genome sequence within a matter of days for less than 100,000 yen. This enables many applications, not only in medicine, but in many other fields as well. The Human Genome Project thus began with the exploration of uncharted territory and the drawing of rough maps through it. Eventually, the roads were paved, making further exploration easier for those who came later. Perhaps the most striking recent manifestation of the impact of open data access has been the development of vaccines against COVID-19. A group of scientists from China and Australia published the RNA sequence of SARS-CoV-2 in a public database on January 11, 2020. It was the very start of the pandemic. That open data enabled vaccine development to begin simultaneously around the world. Before the end of the year 2020, several vaccines were already being used. And not only vaccine development was expedited by the open data, it also became possible to respond more quickly to emerging variants of the virus. Recent moves to do more data-driven research and to provide open access to research findings will help promote research in many areas. At that press conference for the Human Genome Project in the year 2000, several people mentioned their concerns about the ethical and the spiritual dimensions of the research. Those matters cannot be addressed by science alone, and that is the third issue I want to mention today. When studying the human genome, we must keep in mind issues such as the protection of privacy and the risk that genetic information might be used to stigmatize or discriminate against individuals or groups. Analysis of the differences in DNA sequences on a genomic scale seem to show that different groups have distinct clusters of phenotypic expressions. However, those analyses also reveal that genetic variation within any one group is greater than the differences between groups. For example, if we compare the gene sequences of Japanese people in Tokyo and Yoruba people in Nigeria, the individual Japanese vary from each other, and the individual Yoruba are different from each other, more than the Japanese as a whole differ from the Yoruba as a whole. So in discussions of human evolution in the last couple of centuries, and even today, the term race has often been used to classify people based on their phenotypic and genetic traits, such as physique and appearance. However, the notion of race is problematic, not only ideologically, it also has a very weak basis in biology. Meanwhile, genomic analysis of many individual people has made clearer the details of the genetic variation among us. That decoded sequence from the Human Genome Project is called a reference sequence, precisely because there is no single normal sequence. Rather, human gene sequences contain much diversity. Such variations in gene sequences are called polymorphisms, and they contribute to phenotypic diversity in traits like a facial resemblance and alcohol tolerance within families. Our clearer understanding of genetic diversity today highlights the fact that each and every one of us is a distinct, unique being. And it is precisely because humans perceive, think, and develop differently that we have come up with various ways to understand and coexist with others. A related concept that has gained attention recently is neurodiversity. The study of neurodiversity respects differences in people's brains and neural functions, and it regards specific neural conditions not as illness or disabilities, but as individual traits. The goal of this approach is to create a more inclusive society. Here at UTokyo, Professor Yukie Nagai leads a research group in the Institute for AI and Beyond that is developing systems to allow anyone to perceive the world as experienced by people on the autism spectrum. The research is deepening our understanding of cognitive individuality and neurodiversity. That institute, by the way, in a collaboration between academia and industry, led by UTokyo and the company SoftBank. So what lessons does the research on genomics suggest for your studies and research in the years ahead here at UTokyo? Usually, research starts with wondering why. And to answer that question, you formulate a hypothesis, you organize and analyze your observations and data, and you derive results. In general research, however, the rapid advances in technology reversed that process. Rather than doing analysis to answer questions they already had, researchers first collected data, and out of that data emerged the hypothesis for further research. It was this data-driven approach that has led to so many unexpected discoveries. But because data-driven approaches have become increasingly prominent and important, we must remember that data alone cannot provide insights into the complexity and wonders of existence. Human inspiration remains indispensable. At that joint press conference, Dr. Venter responded to objections that genome sequencing is an example of sterilizing reductionism that will rob us of our inspiration. Rather, he said, and I quote, "The complexities and wonder of how the inanimate chemicals that are our genetic code give rise to the imponderables of the human spirit should keep poets and philosophers inspired for the millenniums." New technologies can radically transform society. That was the case with stone and iron tools, with a compass, gunpowder, a movable type, and the same may be true with the internet and artificial intelligence. To create a better society, we must think about the best ways to use those transforming technologies. Right now, there's much debate over the use of generative AI, but those discussions should not be limited to questioning the value of these new tools based on how they can be used now. So rather, we need to discuss in depth and across disciplinary boundaries what significance the new technology might hold for our planet and for human society. At UTokyo, that perspective resonates with our emphasis throughout the university on education on ELSI, ELSI, that is ethical, legal, and social issues. It also aligns with the widely advocated principle of RRI, or responsible research and innovation. RRI refers to the approach of first clarifying what kind of society we want and what values we should pursue. We then identify the challenges faced by our society today, and we adapt and pursue our research toward the innovation and technological development needed to meet those challenges. I encourage all of you entering UTokyo today to believe in your potential. While you stand on the shoulders of giants and apply the wisdom of those who came before, please also question the assumptions that might confine your thinking. Do not only pursue mainstream research that everyone else is working on, but also venture into niche areas that you find intriguing. I myself have spent nearly 30 years working on microfluidics, which is an interdisciplinary field at the intersection of physics, chemistry, and the life sciences. It used to be that an international conference on microfluidics would attract only 100 or so participants. But now, such conferences bring together over 1,000 researchers, offering them a stimulating experience and exposing them to many new ideas. And please believe not just in your own potential, but also in that of others. So your experience and your research at this university will become so much richer when you discuss topics from various perspectives with friends from many different fields. The success of the Human Genome Project was made possible by dividing up the work among international teams. Furthermore, in the 2 decades since that project ended, research methods have become much more diverse. Expertise in only one field is no longer enough for cutting-edge research. Now that information spreads so quickly, new research techniques can be adopted by anyone. If you can't use some technique yourself, you can collaborate with others who can use it. Always keep in mind the broader connections that make your collaborations more interesting, broader connections that underlie your own specialty, that make your collaborations more interesting and enjoyable. Reframing problems from different perspectives will reveal hints for new answers. In my own research field, I have seen a tremendous increase in the number of people brought together through similar interests. I hope that all of you will also feel the excitement of interacting with many other people. So congratulations once again on your admission to the University of Tokyo, and I look forward to seeing you all lead fulfilling lives as members of our academic community. And remember, believe in your own potential. Respect the diverse perspectives of the people around you, and make dialogue the centerpiece of your exciting journey of exploration. Thank you all very much.